My name is Jeff Welsh. I'm in product management in our compute organization. I think I'm here to talk about these enterprise workloads, which I think might relate to Bobbyism too, wherever the vintage term came into play. Because one, I really like that term because I think it's really important that everybody recognizes, as do we, that enterprise is a substantial use case for many of our customers on cloud, and everything is not new that's old again or whatever. Bobbyism number one, I love those things. It's really where we're focused on playing. So in the compute organization, let me set the stage first. Compute for us is defined as kind of our infrastructure as a service offerings with a few small exclusions that will be discussed later today. So we're really talking about the virtual machines, our compute capabilities. In our organization, we have our TPU and GPU and other accelerators. We have block storage and also our enterprise solutions, such as our VMware, SAP, Microsoft type approaches as well. So I'm going to cover effectively that broad spectrum. And please let me know if there's any questions, but I'll go ahead and jump right in here. So when we think about how, first, I want to position how we think about infrastructure as service in our overall cloud portfolio. We have a variety of clouds that are focused on, like, if, for example, security cloud is based on our Mandiant and Chronicle and Cloud Armor type protecting security offerings that are cloud-wide. We're really focused in on the modern infrastructure cloud today, at least in my section here. I think others are going to touch on these other areas. And when we think about the challenges that we're seeing in the field today, I think they're very exemplified by what AI is bringing to the table, and that is dramatic increases in the compute requirements in order to meet our customer workloads. I think AI exemplifies this, but it's also potentially an outlier. We've seen a 10x per year growth in terms of the compute capacity required to train AI models, for example. So the question is, how does this relate to enterprise workloads? And we see similar challenges there. 5, 10 years ago, we could all ride Moore's law, right? We could understand that transistor counts are going to double along with the performance, and price is going to drop pretty regularly. I think it was 18 months, right? We're starting to see that plateau out. We still are seeing transistor counts double, but we're not seeing as such a performance impact. And this is why I think we're seeing a lot of processors that are now coming out with more cores, but not necessarily higher clock frequencies. And so when you think about the inability to throw hardware, it's compute power at your processing capabilities, this introduces whole new ways to think about how you're going to solve your problems. Similarly, we're seeing memory prices kind of flatten out as well. And we're not just making these dramatic leaps and improvements in the technical underpinnings of our workloads that we used to be able to rely upon. And so from our perspective, when we think about how we're going to handle this from a Google Cloud Infrastructure perspective for your enterprise workloads, we're really thinking about how do we optimize our infrastructure to meet our customers' requirements, to really meet the needs of their workloads and not just have a better speeds and feeds approach. And so if you look at the way we think about in the compute organization, as I mentioned, we also have the AI capabilities, the TPU, GPU, et cetera, and that whole software stack. We think about AI-driven workloads. We're seeing more and more of these come to fruition. I think as you see enterprise applications start to adopt AI, you're going to start to see even more of the benefits here. It's not the thing, right? It's the thing that maybe makes it better. And so you can imagine something like SAP and the amounts of data and business important and business critical information that's stored in enterprise databases that can be analyzed, and you can have new insights from AI abilities and introspect that information. We're also seeing a lot of cloud-first workloads. We still do see, of course, a substantial amount of vintage workloads, virtual machine-based, et cetera. But we're seeing more of this desire to try to simplify operational day-to-day patterns by moving to those more cloud-first workloads as well. And then what we're also seeing a substantial amount of still, and I don't anticipate this really going down for who knows how long, right, are these enterprise workloads. And these are more of those traditional vintage workloads, and much prefer that to legacy. And so this is how we think about when we look at the workloads we see from an infrastructure perspective, how do we build that infrastructure? How do we optimize that to meet those workload requirements? And so we're focused on performance, and reliability is a big push for us. Security is something that we bake into the infrastructure from the ground up. Cost is always an important aspect here. A lot of people refer to price performance. We still do see that as well. And then we also are, as Alphabet as a whole, are very focused on sustainability. That is actually pretty important to many of our customers who have board-level corporate mandates to meet sustainability goals. And so we provide some unique opportunities to help our customers meet their internal requirements as well, while benefiting Alphabet as well. So let's jump into here. One thing I want to set the stage on is a technology we introduced at Next last year called Titanium. Titanium is our approach for, you're going to start to see this become more pervasive. It's our approach to helping to optimize the infrastructure for workloads by trying to, if you will, break out of the server box, the sheet metal, where we find ourselves at times limited by the compute power, the I/O power that's in offload chips, et cetera, and we're trying to expand this and really disaggregate our performance capabilities. And so what Titanium is going to bring to us, and I'll get into a little bit of details. One, yes, we have our hardware root of trust. We've had that in the server and the host for quite some time. Titanium is allowing us to really start to leverage the global Google fabric for the global network that I think we're going to have another session on later today and more in depth as well. And importantly, it's introduced the concept of what we're calling tiered offloads. And a tiered offload is how we can take the traditional kind of NIC level offloading, like 15, 20 years ago, we had TCP chimneys, or TCP offload engines, right, to handle the segmentation and the reassembly of TCP packets, of jumbo packets, for et cetera. We can still do that in the host. We do that much more efficiently today with smart NICs, where now we can offload I/O operations as well as security, et cetera. But what we're introducing is the offload processor and really disaggregating this from the host itself and having tiered offloads. And what this is really driving is, yes, within the host, we have the standard offload capabilities, right? We're going to offload your SSL encryption, right? We're going to offload the jumbo packet, segmentation, et cetera. But we're also saying, okay, we can, if we limited ourselves to the capacity of a smart NIC, for example, there's a finite amount of capacity that a smart NIC can do in terms of throughput, et cetera, right? So we simply offload from the CPU to the smart NIC in the host itself, and we hit yet another roadblock or another limitation there. So our approach is to also offload within our underlying infrastructure that provides Google capabilities for all the properties, the 14 applications with more than 1 billion users each, that also powers Google Cloud. And so this allows us to offload our compute capacity, for example, to Borg. Borg is our scheduling engine. It's kind of the core of the global distributed application that runs Google. So we can offload capability for scheduling into that regard. Now, we also have something out here, I'm only talking specifically storage in this example, it's called Google Colossus. This is our global distributed file system. And so when we think about storage offloads, we're actually offloading into the underlying infrastructure as well. And so some of the benefits of this are that we see from a CPU perspective, compared to the last generation, our latest C4 server, which I'll talk about in more detail, has an 80% improvement in CPU responsiveness, meaning the time it takes from, say, receiving a packet to being able to operate upon it, right? We have, from a storage perspective, we have a substantial ability to increase our performance capabilities of block storage, for example, without having to introduce new products. So something we'll touch on today is called HyperDisk. It's our next generation block storage service. When we launched that at Next last year, that launched with, if I remember correctly, 450,000 IOPS.
Can you back up one?
Yep, sure, absolutely.
So this looks a lot to me on a hyperscale, obviously, like a SAN on the right and a node on the left, and you have Borg in the middle with a dedicated, I don't know what word to use because orchestration comes to mind, but that's so overused. That more or less what you're talking about. That seems like the innovation here is sort of middle section with Borg.
I would highlight this as more of a logical diagram and not an architectural diagram.
Okay.
So I wouldn't assume that Borg's always in the middle. This is just kind of a flow. If we're looking at storage offload, we offload from the host itself. Borg helps schedule across our distributed file system.
Yeah.
I believe in one of the later sessions, our network discussion is going to talk about a similar approach for networking, which will look different.
Great. Thanks.
Right. So when we think about the offloads, right now we're focused on security, storage, and networking, and always looking for ways to expand that.
So when we're looking at the offload at Titanium, it's not just a way for Google Cloud to be more efficient with the resources that you have, meaning being able to run more workloads on a given set of equipment, but if you go to the next slide where you're sharing the hero numbers, we're seeing customers are seeing lower latency in real time workloads as a result of the offload.
Yeah, absolutely. There's the direct customer facing benefit of exactly that, the improvements in latency for CPU, for example. But as I was mentioning, when we launched HyperDisk, we launched at 450,000 IOPS. Because of this tiered offload, we can actually now tune not just the host, but our backend systems as well. And so we're able to deliver to our customers a 200,000 improvement in IOPS on the same systems. And this is really the value of trying to break out of the sheet metal, if you will.
So previous to this, if I was a customer looking to get the most out of my cloud infrastructure, I had to do these optimizations myself. I have to, buy bigger instances and then go and basically engineer those solutions. Google is now taking that workload off of me, and I get that benefit without needing to consume more resources than I need.
I think that's a great way to phrase it. We're participating in that optimization. So what you described is maybe 10 years ago, well, you can throw bigger CPUs at it.
Right.
There's only so much you can do at this point. And if you do, say, choose a larger instance in order to have more IOPS, like more cores to IOPS ratio, then you kind of throw that price performance ratio out of whack for you. And so we're trying to be more fine-grained, allow customers to meet their requirements with this approach. And so by taking on this as well, to kind of with Titanium, our infrastructure, we're able to influence that for customers and provide some of that more optimization on the infrastructure as well. Now, some other benefits of this you'll see is, again, gets back to reliability. We're starting to introduce with this tiered offload system the possibility of doing non-disruptive maintenance. We've had live migration for some time, and we're great at that. But now with Titanium, we're able to even perform some other concept I'll talk about called dynamic resource management to really optimize the instances as well.
Can you elaborate on that?
Yeah, I've got that in context of an instance itself.
Okay.
Let me talk about that slide coming up here. Before I get to that topic, though, because I'm going to hit on, I think, 3 specific instances to really focus in on, I did want to put our portfolio of virtual machines in context here. So the way we think about instances largely are broken down into 2 general categories. General purpose. These are kind of traditional instances you might want to run for a web server, et cetera, maybe your high-performance database servers. And then we have our specialized workloads where, for SAP is a very big and important partner to us. We have very large memory requirements. So we have memory-optimized virtual machine shapes there. If we had our accelerators, if you had some GPU, TPU type requirements, that's where we have our you can see these over here, our A-series shapes that are focused in that regard. So what we announced at Next just a few months ago is this set of virtual machines in the bottom here. I'm not going to touch on all of these, but I am going to start talking in more depth about a few of them. The first is our C3 metal shape. So this is, and in fact, all the instances you're seeing today are really enabled by Titanium. So this is going to see the direct impact of this investment. So a C3 metal shape for us is a bare metal instance that allows the end user to have full capacity of the hardware itself. There's no hypervisor running there, right? So we see this if you want to bring your own hypervisor, it's a great use case. There are some other requirements, like for if you want license optimization, this is an option for you now as well. And so with the C3, you can see our shapes down here, providing 192 vCPUs, varying levels of memory and storage capabilities with up to 200 gigabits per second of networking. All of these are also fully compatible with HyperDisk. So you have the capabilities of the advanced storage networking that is now available with HyperDisk, including storage pools for thin provisioning, deduplication, data reduction, et cetera, to really manage your storage spend as well.
Is this C3 only? Is it C3D also? Or is these particular shapes of C3?
Starting with C3. This is just the first instance we announced. Absolutely. Yes. I mean, that's with bare metal, it's harder to have shapes. It's specific servers, right?
Well,
yeah.
Machine, that's the terminology. I just mean, there's 15 shapes in the C3 catalog, and you're showing the 3 high-end ones here.
Yeah.
Are those the metal machine?
These are the metal machine shapes, yes. Yeah. And so this will continue to expand, yeah.
No hypervisor running?
No hypervisor running. You can bring your own hypervisor.
Yeah, it's bare metal.
So this is, you folks kind of glossed over this at Next. This thin provisioning thing is kind of a big deal.
The thin provisioning?
Yeah, it's kind of a big deal, especially as you're talking about bringing the the ability to bring hypervisors. One of the things have been with cloud pricing to be able to match my operating model on-prem has been this inability to thin provision. So I have to say from you guys are burying the lead a little bit and say, oh, thin provision is here. Something that as customers we've been asking for a long time.
Mm-hmm.
So just a comment.
Thin provisioning regarding instances or storage?
Storage. So when it
right.
comes to storage, because one of my biggest expenses, especially when it comes to operating a hypervisor in the cloud, is storage and needing provision. I need to over provision storage for my VMs. So the model never worked traditionally, and thin provisioning of storage is a big deal.
Yeah, no, it's great innovations that we have there. I don't want to steal thunder from another presenter.
Oh, they're going to talk about it.
Yeah, there's a storage section. Yeah, thin provisioning is great. Storage pools, advanced storage pools we just announced as well allow you to, summary, allocate large blocks or, acquire large amounts of capacity and then provision it to all your instances. You can manage a pool of capacity rather than individual volumes. The advantage there largely is, one of the advantages is you don't end up with stranded capacity that's just never going to be used because you overestimated or underestimated, right? So, but that's going to come up in more depth in another session. But I'll be sure he knows about that.
So the C3
Yes.
machines, the networking and all the VPC and all that stuff, how's that play out? I mean, is it something you have to bring your own?
No, so this is the titanium. So everything's running in for what's required on the host itself in the offload at that tier. And then storage is also, all the capacity for HyperDisk is in the second tier. So for VPC integration, it's native. You can drop a bare metal instance or host into the same network as any other instance you have running. It's all transparent. So it's self-service, bring your own operating system, hypervisor, et cetera. And there you go. So if you have applications like in the past, VoIP, large numbers of high packets per second has been a challenge. Those are no longer an issue.
Or if I have an application that requires layer 2 networking, I can now create that within a hypervisor on bare metal and still integrate with my solution. It's pretty cool.
Yeah. Okay. All right. So this is where I wanted to have a chance to discuss dynamic resource management. When we think about bare metal is a big announcement for us. The C4 and N4, our next generation general purpose workloads, are also very important to our strategy. So C4 is what we would consider optimized for high performance. This is an instance that's going to come in NUMA-aligned shapes. You're going to have the highest memory bandwidth with the DDR5 performance. Compared to our C3, you're getting up to 25% improvements across the board. This is where you're going to want to likely run your things such as database instances and so on and so forth. Now, you might have a front-end tier, if that's your back-end tier, that we think the N4 VMs are really well positioned for. These are balanced performance and really intended to be really cost performant for you as well. So these are flexible shapes. So we have the capability of, with custom machine types, of a user defining the exact instance shape they need, where the C4 is fixed, and so we have the memory alignment. What's important about the N4 is this is where Titanium really starts to play as well, is this dynamic resource management. So with an N4, for example, we can do things such as monitor the performance of an instance and say this instance, maybe it's running at a lot higher CPU level, and we can actually move it off of a host to a different one where it might perform better. And we can do that with Titanium and live migration under the covers without the user having to worry about that. So it helps to be a very high performance and flexible performance offering, right? To really meet those workloads. So if you need more scalability and flexibility.
So Jeff, you have some sort of a policy-based approach that says that, I want to be able to achieve, I don't know, some number of operations per second. And if it starts falling below that, then I can you would automatically live migrate it to some other solution that
the customer doesn't fit that out there. What we're doing is we're monitoring. They don't define that. We're looking at the systems underlying it and say, hey, maybe this host.
So if he's got a noisy neighbor or something like that, you would automatically take action to move it to something that doesn't.
Yeah.
Not bad.
Yeah. So it helps us bin pack. It helps us ensure the best performance for our customers.
Right.
Okay. The next host I want to talk about is the next generation of ARM. So this is what we launched called Axion. Google has a long-standing history of hardware engineering, right? I think a great relevant example is the TPU that we also announced just at I/O 2 or 3 months ago, the 6th generation called Trillium. We've been building our own processors for quite some time inside of our data centers in order to feed the TPUs. We also build our own optical circuit switches as well that are, a million mirrors that can be reconfigured at any time to take on any new, protocol, any new standard of networking and improve performance. And so we're starting to focus in on ARM as well. We're seeing ARM adoption is something that's very interesting to our customers. There's many workloads that we can see listed out here that it's very applicable for, and the capabilities and the ease of migration to ARM, the capabilities are improving, or the workload support is improving, and the migration is becoming less and less challenging. In fact, it's pretty straightforward at this point. So from our perspective, ARM for us, when we map these out to a comparable, like kind of similar spec'd out x86, we're seeing a substantial performance improvement. Of course, the energy consumption is always exciting as well. And so a lot of our customers are looking at this for their workloads. Now, I will highlight as well, because of our offload approach here, the storage capabilities of things such as HyperDisk are not limited or restricted to x86 or AMD, where we maybe have specific hardware in the host. We're actually able to have all of our HyperDisk storage capability for ARM as well. So it starts to really fit into the enterprise workload portfolio quite cleanly because you're not restricted by different storage workloads in effect. Similarly, we have the network performance that comes along with Titanium as well. And as we add more and more capabilities to Titanium, you're going to see that have more and more of an impact on ARM as well.
So Titanium is your own IPU, or are you using, so it supports storage, security, and networking capabilities, offloading?
Yeah, Titanium we've been public, it's co-developed with Intel,
Okay.
infrastructure processor unit. You can think of that as a smart NIC, like there's many other vendors out there. It's part of our the IPU is part of our Titanium strategy. So that's kind of the hardware in the host, and then we offload with software as well in our additional tier.
And it plays well in the ARM space because all that stuff that you've got configured for x86 now works for...
It's PCIe,
yeah,
right? So
yeah,
it's pretty
yeah.
portable at that point.
Yeah.
Okay.
So before you continue, let me see if I
Sure.
understand this. You're talking about optimization of enterprise applications. So in my mind, I'm leaving specialty like AI training or HPC out of it, right? So I'm a customer. I have an estate of a few thousand enterprise applications. You're sort of categorizing them, and you have this new Titanium for some of the most demanding. I'm thinking HANA or like a kind of, it's something that's heavy data wise and heavy processing wise, analytics wise. So that's where Titanium fits in, and then you have C3 and N3 more standard virtualized shapes for a broad swath of those applications, and then you have the new ARM services that's going to debut with C4.
Mm-hmm.
That's also a virtualized, not virtualized. Sorry, that's a shared resource, not metal as a service or anything like that.
Mm-hmm.
And we're talking now about like a lot of this pretty heavy cloud native stuff, and so with that, you feel like you're painting a pretty good, coverage for my estate and especially with the off-prem and on-prem options that you have and everything. Now I can see how I might run anything, especially with the addition of Titanium. Do I have that more or less right?
Yes, I think the one nuance I would say is Titanium is not just for the high performance, like the highest performance workloads. It's really an enabling technology. So something like this Axion chip for a web server can still use Titanium technology to access the block storage on the back end, right? So it's just more, Titanium's an underlying foundational technology that's allowing us to build more and more use cases on top of it.
So it's going to start with C3,
Mm-hmm.
but you hinted that it might, I'm not quoting you,
Mm-hmm.
be clear, that might extend to C3D, could extend to C4A at some point, like it's a more horizontal.
Are you talking metal or Titanium? Because
I'm getting confused between the two. I'm thinking Titanium and metal, both. I guess.
Yeah, Titanium's kind of an example of how it enables the metal services.
Oh, okay.
Right. So Titanium actually works on C3 VMs as well. Now it's expanded to N4, C4. C4A, well, Axion right here, and so on. So it's kind of an underlying technology across everything.
Yeah.
Okay.
So if we think about titanium is a part of the infrastructure we don't physically see, but we get benefit from.
Correct.
So if I'm consuming native cloud storage services, those native cloud services that I'm consuming from a VM could be powered by titanium.
Right.
So going back to the SAP HANA example, I need to buy bigger CPUs, bigger memory to get the performance out of SAP HANA that I need.
Mhm.
If I'm leveraging titanium, which is an invisible upgrade from the Google infrastructure before, day one, I might have gotten X performance. Now, because now the titanium is lowering latency from networking, storage, into the CPU, I might see benefit that I didn't make a performance change or a configuration change. I'm just seeing the benefit of better infrastructure. So I can, in theory, either get better, faster business results, spending the same amount of money, so price performance, or I can save money by going down to a lower offer from instance type.
Absolutely. So titanium and storage is a great example of that. Like I said, we launched HyperDisk. It was HyperDisk Extreme was 450,000 IOPS. We're now up to 650,000. Our users get that benefit without having to change anything. They don't need to re-provision storage. It's just possible to go faster.
See, it's more horizontal even than I thought, really. You
Yeah.
have your various deployment options from hyper-virtualized, whatever, doohickey, cloud natively,
That's very technical
right?
term.
Right.
Thank you.
Yeah.
All the way over to, I have a box in my closet that I can hug that says Google on it.
Right.
And all of those can benefit in one form or another from titanium if you implement it. It's in theory. I don't mean like at the
No, yeah, you're absolutely right. So back to the point about optimizing your infrastructure, we also decouple the CPU performance from the network and the storage performance. So historically, I
a
need more
critical
IOPS. I
element.
got to go, many more vCPUs than I actually need for the application. Well, now we can tune that because we've decoupled.
That's a critical element of
yeah.
it. Yeah.
Sorry.
Okay.
And
So I think
titanium
they
is
said,
only,
he said that titanium is invisible. Is it completely invisible, or do we actually get access to that if we wanted to do something custom?
It's under the cover.
It's under the cover, so it's invisible to
But
it.
it's interesting. Like, what would you have in mind? I mean,
I have no idea. It's just
Okay.
it's just more a question from an architecture perspective. If I said, okay, there's this coprocessor out here that I know about, an offload processor, and I know about it, maybe I want to do something. If I'm doing something very application specific, I can do some offload into that.
yeah.
Take advantage of encryption decryption code, running on an offload or something like that.
Right.
Right. If I'm doing a specialized workload.
Yeah, that'd be interesting.
Right.
Like an FPGA type in the
Yeah, something like that. Right.
It's invisible to that
But,
extent.
but
it's
today-
invisible to that.
Yeah.
Okay.
but today titanium is available on C3 solution, C4, N4,
Yeah.
C4A. Those are the four,
Yeah, and it's HyperDisk as well.
and HyperDisk. So anybody that uses HyperDisk is going to be going through titanium, or regardless of the instance, or?
Yeah, so you'll see HyperDisk where it's compatible today, and we're working to expand that.
Oh, I
All
got you.
titanium.
I got you. All right.
I'd like to think of these things as this is taking the bit that is the cloud provider, doing the multi-tenancy, doing the separation that used to be done in the hypervisor, is now being done in the PCIe card. And so then you get access to everything that's in the physical CPUs. It's not being taxed
Right.
by doing all of these things.
Yeah.
The control is now in that hardware and given back to the cloud vendor.
Hypervisors are very lightweight these days, but there's still a little bit of tax there. So if you need like the metal performance, we have that capability. Okay, other enterprise workloads. Let's get into more specifics about Microsoft on Google Cloud. I think in the past we've gotten questions about, is Google a good place to run Microsoft? And the answer is absolutely resoundingly yes. We've been running Microsoft workloads as a first-class experience for many years. You can see we first launched in 2015 support for Windows Server 2008 and 2012. Right. Since then, we've continued to enhance our capabilities to support specific enterprise workloads. Like there's a lot of focus you can see on this retrospective on support for advanced SQL Server capabilities, where we continue to invest in that area as well. So today,
Sorry, what
yes.
do you mean by advanced SQL?
Well, supporting high availability groups, clustering, things of that nature. We need to support the enterprise workloads. It's a challenge if we can run SQL Server, but on local host only with local SSD, et cetera. We're trying to meet the enterprise workload requirements.
Okay.
Yeah.
So you mean as a service?
It's a first class service, yeah, fully supported on our cloud. So the reason that we see our customers selecting Google for Microsoft workloads, I think we could break down into these three categories. So first is savings via cost optimization. We're very focused here on helping our customers optimize their license spend. So for example, we have this technology, SMT stands for symmetric multi-threading. We allow our customers to disable symmetric multi-threading, which changes the numbers of vCPUs to the operating system. Counterintuitively, this actually improves your price performance because if you add a handful, maybe 10% more cores, but you disable SMT, you get the same consistent performance, like your performance profile doesn't change, but your licensing costs are, say, optimized. Custom machine types, as we mentioned with, for example, the N4, again, allow you to dial in the virtual machine shape to meet your application requirements and then also tune based on your optimization requirements for your licensing. We also find customers that use custom machine types in order to help bin pack more closely. Like say I've got, there's a licensing cutoff that for 4 cores, even if you're using 1, you're still paying for 4. Well, now we can help customers maybe enhance and tune the virtual machine shape and combine their instances of SQL Server, whatever it might be, onto a host to optimize their instances. We also have some, I think this may be covered in a later session, some right-sizing recommendations that this is an example of where we're really starting to focus AI and how it makes the thing better. The thing is Windows or SQL Server, but with advanced ability to look into usage patterns, data patterns, et cetera. With AI, we can start to tease out optimizations that might not be readily apparent as well. So you're going to see more and more come to fruition in that space. We're also very reliable and performant, as we mentioned, right? So if you deploy, if you want to deploy Windows on sole tenant node, right, where you're the only host on the VM, you can get all that capacity. And now with the metal shapes, you can also deploy on the bare metal as well if you'd like. And of course, this thing called Titanium is underlying a lot of this infrastructure as well. So you think about SQL Server workloads and the data storage performance and requirements, it's a great capability for that. Live migration is a good differentiator for us that it really helps with some of those more less cloud native workloads to have better maintenance experiences, right? With the ability for live migration and Titanium under the covers, we're able to help our customers out, improve their reliability. We've talked about storage pools as well, and then we also have multi-writer capabilities for SQL Server.
So is live migration something the user has access to, or is it something completely under the covers?
It's something that, like, if we needed to do host maintenance, we can migrate them off and not have to involve the customer, right? So they generally wouldn't see, some RAM starting to have some bit errors or whatever it might be, so they don't.
So if they were interested in upping their performance or scale or something like that, they couldn't use live migration to do that, to do it different instances or anything like that.
Well, so live migration would move from like the same VM shape from one host to another.
Yeah. No,
and so if you wanted to change the size of the shape, it's more involved. Like you wouldn't live migrate from 2 to 4 cores, for example. So that's more of a little bit of a migration. You can restart and change the shape.
Yeah.
That's different than live migration.
Okay.
Yeah. And then from ease of modernization, Bobby touched on some of this where we talk about the capabilities of moving workloads to some of our cloud first services. That's absolutely a use case our customers do. But what's also really exciting, and I think you're going to see this, is some of the Gemini AI-based .NET modernization capabilities that we're bringing to the market as well. This is a place where AI is really starting to be able to shine, I believe.
Can you give some examples?
Again, I don't want to steal anybody's thunder, but you can look at your .NET code. You can any code translate from one language to another, right? Maybe perform some code optimizations to enhance the. I've got a really long running SQL loop here, right? Your SQL explain didn't tell you how to improve it. AI can maybe look at that. That can lower the performance requirements. So, code optimizations in general. Okay, and the other thing is, if you're not aware, we have a partnership with NetApp to provide NetApp cloud volumes, and I think this is also going to be discussed in more detail. It's a first-party experience where You're an on-prem customer coming to the cloud, right? You have NetApp on-prem, you want that same experience, we offer that. Importantly for Windows workloads, this provides that scalable SMB file system that many of those applications do prefer. So we have that capability for your applications to bring them with the same storage technology as well. So you don't need to think about how do I re-platform my storage, right? So it's a great option for our customers in that migration process. Okay, so yes.
Do you see titanium, before we get off this, do you see titanium as something that with Ansos people can have in their own data centers, or?
I mean, so as Bobby mentioned, with GDC, the distributed cloud, there's hosted, like software-only versions, and there's also hardware versions. Those hardware versions could absolutely take care of it. Could have that. Software, of course, it's not hardware that we sell, so you couldn't put that in your own hosts. But right now, we're not doing that, but it's possible.
Okay.
All right, another big enterprise workload for us that we see a lot of interest in is our VMware estates. Google has a very strong VMware offering called our GCVE, the Google Cloud VMware Engine. This is a true integrated experience where you are able to deploy your VMware environments that have full integration into Google Cloud. So similar to bare metal being directly configurable within a VPC, you have the same experience with your VMware clusters. Right, so this allows you a quite simple and fast way to deploy VMware environments. It's a 3-click experience to deploy a private cloud, a VMware private cloud. That takes approximately an hour to get up and running. And at that point, you have all the capabilities of VMware, all the ecosystem provided by VMware, including HCX, to make it very simple to move your VMware on-prem workloads to GCVE and Google Cloud. So this is a great experience our customers like because it also provides not just the infrastructure integration, but you have access to all the services, Vertex, et cetera. So if you wanted to start pulling Vertex or Gemini models into your applications hosted on VMware, it's a nice seamless integration there as well. So it really is a first-party experience for VMware on Google Cloud. Now, with that experience, we also are able to meet the enterprise workload requirements. So we have that 4 nines availability, and we're going to provide you up to 32 nodes in a single cluster, which is the largest in the industry. Right? So you can really, without stretch cluster, so you can really get this the capacity up there that you might be running on-prem. We are a great target for those migrations into a cloud experience.
So back to the previous slide, just for a sec. I want to make sure I clarify this because VMware, as of this recording, just made an announcement that their own service no longer has a pay per use model, dynamic pricing. They've sunset that, so I still can do dynamic pricing for my VMware host within Google Cloud.
So when was this announced? Like just
like
today?
3 or 4 days ago, beginning of the week, they announced that that dynamic host on their provided service on a different cloud provider is no longer supported. You have to buy it at 1 year at a pop.
Right.
Whereas I've used this service before, and I know I could just spin up a host and spin down a host.
Yeah, I'm not sure what they announced with another cloud provider.
Okay.
But
well, I'm to clarify with you folks that's still accurate, that you can still do pay as you go.
Yeah. In fact, there's the last slide here is going to announce the new commercial model that we have available with them as well. Okay, and then as we mentioned, Titanium provide that seamless network integration, and again, the 200 gigabits east-west network throughput as well. And so let's jump to some of the business benefits of this. We do find our customers find, because of how easy it is to migrate VMware to GCVE, they get that 50% faster application migration because it really is it's the same exact thing that's on premises and then moving to the cloud. We've seen many of our customers have a 390% 3-year return on investment. And then they get this, I guess one of the challenges with hosting on premises is you need to maintain your own hardware. And if you're looking at older hardware, simply by moving to a modern cloud provider, you're going to get the benefits of all of the infrastructure that we've built at Google that they can run on top of. Then I think the last thing here is this VCF. So we're the first cloud provider that supports VMware Cloud Foundation license portability. So we now have 2 consumption models effectively. Customers can use VCF license. They've purchased an on-premises VCF license. They can simply bring that to Google Cloud. Right? So it is move that license over, or they can purchase from us with the VCF license included as well. It's a very easy commercial transaction to migrate to GCVE.
And if my VC contract is expiring in 18 months, at the end of that 18 months, can I transition to the Google provided licensing simply, or is...
You know, I'm not quite positive about that right now. It's still very new,
Right.
but that's a great question. Someone can follow up on. Okay. All right, I think the last topic I have to discuss is SAP, and we've briefly touched on this. But when we think about workload optimized infrastructure, SAP is one of those unique beasts, given the in-memory capabilities and local storage desires. We haven't dug much into one of the newest instances we released next, called the X4, but this is really what's we target at these memory optimized requirements where SAP HANA certainly fits. The X4 has lots of local storage, up to 32 terabytes of local SSD, and gets to the memory requirements needed for these environments. We are the industry leader in terms of uptime SLA for SAP on Google Cloud at the 3.5 nines. For the single, MOVM stands for memory optimized VMs. So when you're running a single memory optimized VM, we're going to provide this 3.5 nines uptime SLA for you. We, again, just like with GCVE and all of our other really strategic applications, we have this integration with all of our other services. I think you're going to see a lot, just in general with SAP, AI vendors, for example, building their own models and applications to analyze SAP data. Because that can all be built with Gemini on top of Vertex, et cetera, these are kind of items that can plug into the model garden, and you can easily integrate that with your SAP applications as well. You will see a lot of excitement.
How does the Vertex integration with, let's say, VMware, which I'm more familiar with than SAP, work in this case? So I would develop and train and do all the back-end work with Vertex, and then I have a model that I could use for inferencing, and somehow I could plug that into a VMware application? Or?
Yeah, I would say that, so Vertex is kind of your PaaS. You're going to build on top of it, as you mentioned, right?
Right.
So what are you going to build on top of? You want access to that data. And so that native integration of the data, the ability easily, something as simple as access maybe an NFS share out of VMware or whatever it might be, to get that data out without having to move it around so that it can be accessed is maybe an easy way to think about it. But then on top of that, those models and those applications you build, that are, the actual model that infers against the data, then that can also directly access through our native integration the data that's on SAP or wherever it might be.
And where would the model be inferencing in this case? Would it be inferencing in the Vertex cloud, if that's the right term, or would it be inferencing in the Google CVE or SAP? Or
so if you're going to build on Vertex is that platform as a service that's going to provide the services itself. So you're going to run it inside of Vertex.
So it's just an API call to Vertex, and I get a response, and all the back-end compute is happening in the Vertex environment.
Vertex is a platform, yeah. Yeah, it's going to provide that processing for you. You can build if you wanted to, right? We have the capability. You could build the models at the lowest level, build them up, and run them standalone as well. But Vertex is a prime approach for our customers to accomplish those goals.
So is Vertex going to be an option out of SAP has this AI hub for being able to just say plug in models when their model is not enough? I can plug in a different model so that from a friction perspective, as a customer, I have low friction coming from my SAP data to and leveraging the cloud service.
Yeah, I think what I suspect we'll start seeing, and I know there's going to be smarter people talking about this later. I think we're going to start to see the evolution of like a model marketplace.
Mm-hmm.
We call this a model garden today, where vendors will create application specific or use case specific models and capabilities that you can go through the SAP or through the model garden that we have that leverages Vertex to analyze the data.
So it's a two-way integration. SAP can build their model garden. You can build your model garden. Since you have the API hooks into SAP, you can offer similar fit and finish just based on what angle you're looking at the problem.
Yeah, absolutely. Yeah, 100%.
Is there a particular
target you have for SAP on Google Cloud? Because SAP segments its universe of customers pretty well and tries to drive customers in different, like some to the SAP Cloud and the different flavors there and so forth. So is there like maybe a size or a particular like a migration strategy or anything like that you're targeting with this?
Let me see what my next slide is. Yeah, this is maybe a good one. So we're very tightly partnered.
I did that for you.
Thank you. Great segue. We're very closely partnered with SAP. So, for example, for migration, we participate in the RISE experience, right? And so we have a large amount of experience migrating SAP to Google Cloud. In fact, SAP runs their offering on Google Cloud.
Yeah.
And vice versa. Alphabet is an SAP customer running on Google Cloud and one of the largest, most complex deployments in the world. So a lot of what we learn about what we need to do to improve our ability to optimize our experience for Alphabet is what we are able to pass through to our customers as well. So it's an ideal dog fooding experience, I guess maybe you would say in that regard. So that whole customer segmentation, we partner closely with them. We're a target for them as well. So we support their entire suite of products, SAP HANA, memory optimized, and so on and so forth.
I'm just wondering because these seem to be moderate sized. I mean, maybe Alphabet's an exception, but these are pretty moderate sized HANA implementations if you're targeting like 64 terabytes or around there, because there's plenty of very large companies with much larger.
So it
HANA
depends on
implementations.
it depends on what you mean by, if you're talking about just scale up, 32 terabytes is massive. Like from a HANA distribution, if you're talking about scale out, then it can get as big. And I'm sure Google, I don't want to speak for Google, it can get pretty big when you scale out. So it really does depend on the application. There's very few customers going up to 32 terabytes or 64 terabytes of a scale up SAP deployment.
That's correct. Our customers generally run clusters, 15 plus servers that provide this whole application, more of a scale out approach. So but of course, everybody always wants more storage and more memory. So we're working on that too.
All right.
So. All right, I believe, that is really the end of my session here. Just to wrap it up, when we think about, again, our approach to infrastructure, it's not speeds and feeds, it's how do we deliver on our customers' requirements for their applications. So from enterprises, we're thinking about how we optimize our infrastructure to meet those workload requirements.
Jeff, you mentioned like 4 or 5 clouds early on, the modern infrastructure, developer, data, security, and collaboration cloud. When I look at GCP, I'm only looking at it from a modern infrastructure cloud. Is that what I'm seeing? Or does it support all those things?
Yeah, so so collaboration cloud, for example, workspace, right? So I wouldn't necessarily bundle that in with our infrastructure services. Security clouds, the Mandiant, et cetera, and so on. They're more focused for those types of approaches, data collaborations, analytics, and so on. It's all related. I mean, it's all Google Cloud, but workspace is a different beast than infrastructure.
And the data cloud would be?
Data cloud would be the spanners, et cetera, the databases.
But it's all
runs on Google Cloud.
Basic Google Cloud
Yeah.
product services, right? I mean,
yeah. Marketing.
Marketing. Oh, okay, thanks. That's all I had to say.
That explains.
I was going to say marketecture, but whatever.
All right. No other questions? I guess I'm turning it over to somebody.
If I'm an enterprise that does run, I'm a Microsoft shop, for example, what's the checklist I would look at to see if my workload arrangement and usage would benefit from, coming off, and over to the Google Cloud?
Yeah, that could use its own session, that answer to that. We have a process we called RAMP, which is an assessment for migrations that does exactly that. It's a whole structured approach to how you assess the workloads, how you define, identify or classify your current state and define your future state architectures and design how you're going to actually perform a migration as well. So there's a whole set of tooling for that. This is also an area where our professional services organization comes into play. I mean, in my experience in the past, many times to answer that type of question, I've seen lots of customers that didn't really know what they had to migrate, right? Because things have been around for 20 years, turnovers happen, and things have just been running, right? And so that's a very involved process, but we've made great strides in simplifying that.
All right, and from your SAP presentation, I assume that if I'm a SAP customer, I would just be referred to you by them when appropriate to get off of their service.
Yeah, I mean, we work with SAP directly with Rise and a lot of their tooling. We work with a lot of their SAP partners for those migrations, et cetera. And, SAP, because it is somewhat of a constrained, it's an application architecture.
Mhm.
We have reference architectures, et cetera, and targets that really simplify that process as well.
Right.
It's not as general purpose, right?
And with the VMware thing, my experience there with companies that were moving to cloud, a VMware cloud on Google, it seemed like a really good fit over the years when my hardware is coming to the end of life and my choice is I'm going to buy a whole bunch of new hardware and refresh or move. Do you see that that scenario changing in this changing world?
I mean, that is still an absolute valid driver for our users, right? They're looking at a hardware refresh, and that opens up their mind to think about many different options. But we also see customers that are just wanting to get out of data centers. And it's just not core to their business anymore. They're looking for, they don't want to get out of VMware. They just don't want to be in the hosting business themselves. So that's one, an additional motion. The other is we see a lot of customers that are looking for DR capabilities. And this is a very straightforward way for DR. No.
And if I were to my DR data center in another city currently, if we would to mothball that and we would have the ability to expand on demand when an actual disaster did occur, just have a core running and blow it up when we blow up.
Yeah, I mean, I could never advocate enough for DR plans that are actively tested on a regular basis and maybe switch over and back somewhat regularly and treat DR not as DR as much as a secondary primary. But then you can evaluate for your workloads how you can dehydrate, rehydrate, perhaps as a phrase. Right. But it's totally API, self-service, cloud experience. So you can absolutely do that.